Hello everyone, my name is Maike Behrendt and I'm going to present here our paper, How Will I Argue? A Dataset for Evaluating Recommender Systems for Argumentations that I worked on together with my colleagues Markus Brenneis and Stefan Harmeling at the Heinrich-Heine University in Düsseldorf, Germany. So in this paper, we publish our dataset that we collected in a research study that you can use to evaluate recommender systems for argumentations. To start with, I'm going to show you some details on how we collected the data. So what we did was a research study on political opinion forming, but we also used an argument recommender system, and we carried out the study over a time period of 4 months. This means that we collected the data at different points of time. So we first did a pre-test, and then the main study was conducted in 3 waves. And the study participants were from the German online population. So it was a representative sample of the German online population. And what we did was we let people discuss or show arguments for and against 2 issues on German nutrition politics that I will show you now. So those were the 2 main issues that were discussed. The first one is, should plastic packaging for fresh food, such as fruit and vegetables, be allowed or prohibited in Germany? And the second one was, should the growing of genetically modified plants for food production be allowed or prohibited in Germany? So those were 2 issues that we hope that everyone, as it is on nutrition politics, that everyone has an opinion about and that we can collect some arguments on. And now I show you how the platform looked like that we used for study. So what you can see here is that the users were shown one of the main issues. This is the one on the plastic packaging, and this is what we refer to as position. So this is the position that was discussed in the study. And then what we did was show some arguments on this position to the participants. You can see here, and those were both pro and contra arguments. So in some groups of our study, we recommended some arguments to the users with our recommending algorithm, but some users just saw random selected arguments. And those arguments were selected by us beforehand, before the study, and these were shown to the users. And what we did first is that we collected what we call conviction. So we just asked the users if they would agree or disagree with the shown arguments to collect their opinion on these arguments. And in the second step, we shown them the same arguments to the same position, and we asked them to give us their opinion on how weak or strong they would consider the arguments, regardless of their own opinion. If they would say, oh, this is a strong argument and this is a weak argument, and there they have a scale from 0 to 6 where they can choose from, and this is what we refer to as the argument weight that we collected. So this is what we did in the study. We shown some arguments to the participants and collected their opinion on it. And just to give you an impression on what argument recommender systems can be used for, if you have such a system, it can, of course, be used to suggest relevant arguments for a specific topic. So if you're just discussing an argument and you just want to know the arguments that are relevant to you, then such a system can learn about your own opinion and what matters to you, and then suggest you some relevant arguments for it. It can also be used in online participation platforms, for example, on political participation, like we did in our study. If, for example, a group wants to make a decision on something, then it's very useful if a recommender system can recommend some arguments for both sides, so pro and contra. And also it can be used in tools for opinion forming. If you just want to form your opinion on a certain topic and you don't know much about it, and then such a system could recommend some arguments for it, for both sides, pro and contra, of course. So, and what we noticed when we did the study ourselves, that there's still a lack of annotated data for evaluating these systems, and that's the main reason why we want to publish the data that we collected. And in total, our collected data sets includes approximately 900 arguments and 600 user profiles. And now I'm going to show you how the data looks in detail. So if you would zoom in to the data, and what you see here is just a really small fraction of the data, then you see here that every row represents a participant. So we collected the data from every participant, and in the first column you see the opinion of the participant on one of the positions that we asked the participants. So for example, the plastic packaging issue, and we asked each participant if he's or she is for or against the issue. So for plastic packaging, for example, or against it. And this is the value that you can see in the first column. And then for each argument, we collected the two values that I showed you before. So the first one is the conviction. So on the right side, the conviction of the argument, of the user of the argument. And the second one is the weight of the argument. So that's a value between 0 and 6. So this is what the data looks like if you zoom in. And if we now zoom out and take a look at all the data that we collected, we can see here the different points of time when we collected the data. So we first did a pre-test that was conducted in April 2020 with a total of 264 participants. And what we did here is that we confronted the participants with arguments for both of the topics, so the plastic packaging and the other topic on food nutrition politics. And we just shown them arguments for both of the topics and then collected the opinion on these two issues. And we did this to firstly, of course, test our setup if everything works. And the second reason is that we can use the data to solve the so-called cold start problem that you have when you use recommender systems. So you can't recommend anything if you don't have some data beforehand. So this is why we use the pretest data for our main study, even if the participants in the pretest were not the same as in the main study. But we can use the data of the participants that we collected before to make our recommendations. So the first main study was conducted in August 2020, as you can see here. And what you see now here is that for every point in time, the matrix of the data also includes the data from the point of time before. So in the matrix for T1, there's also the data included from the pretest. And so it always adds up, so that in the last matrix, we have all the data that we collected. Okay, so in the first main study, what you see here is a very thin line in the data matrix. And this means that in the first main study, we just collected the opinion on the two main issues. So the two questions that we asked the participants, we just collected the opinions on this. And this is why there's just this thin line here in the data. And in the second main study, we confronted the participants with arguments on one of the two topics, what you can see here. And I forgot to show you how many participants we had. So in the first main study, there were 410 participants. And then in the second main study, there were 289 participants. And those were a subset of the 410 participants from the first study before. So these are always the same participants, but of course, there are always participants that drop out during the study. So we had 289 in the second main study. And in the third main study, we had a total of 229 participants. And in this study, we collected the data or the opinion on the arguments for the other issue, what you can see here. And yes, that's the whole matrix of all the data we collected. And as you can see, it looks like if only on this side there's data stored, but this matrix is really sparse. So there are also data points on this side that you can't see. And that's the reason, that's the case because we only showed some arguments to the participants and collected the opinions from them. And the participants could also add their own arguments. So they are all also included in the dataset, but there are not as many opinions on it. That's why it looks sparse over here. So this is what the data looks like. And here are some properties of our dataset. So in total, we have the data of 674 participants. So these are the ones that were included in the pretest and also the main study. And in total, we collected 946 arguments, from which 74 were provided by us beforehand, and 872 were added by the participants themselves. And you can see also some statistics on the average length of the arguments here. Okay, so now I showed you how the data looked like, and we came up with 3 different tasks on the dataset that we tried, but we want to invite you to come up with your own ideas, with your own tasks on the data. But as a starting point that you can try on the data, we have here 3 different tasks that we tried. These are prediction of conviction, prediction of weight, and also prediction of statements. And I will show you what it means in detail on the next slides. And the idea is that you can, given the data from one point of time, you will want to predict the data from the next point of time. So for example, you have given the data from T1, then you can predict the data from T2. So I will show you now what it means. For the first task, prediction of conviction, if we have, for example, all the data that we collected at time point T2, then we can try to predict the values of the conviction in the time point T3. So for every argument where we have data for this one participant, we can predict the value for it, for the conviction, and of course also for the weight. So these are 2 tasks that you can do on the dataset, and also another task that we came up with is prediction of statements. So if you have the data from T2, you want to predict which of the arguments a user would consider as convincing and which not. So you can also do it the other way around, that you try to predict arguments that are not convincing, for example. So we tested these 3 tasks with 2 baseline methods. One was a very simple majority classifier that always predicts the most common opinion of our users and also considers the averaged weight. And one more sophisticated nearest neighbor classifier that uses a collaborative filtering-based recommendation algorithm that was also used in our study. And if you're interested in this, then you can look at the paper of the tool that we used, and also to the algorithm that was used in our study. So these are now the results of our baseline methods. They are not that important, as we want to publish the dataset, and you can, of course, come up with own methods that are probably better than our methods, but just to show you that you can have some meaningful results on the data. We show you here some baseline results, and of course for every task the nearest neighbor classifier works a bit better on the data than the majority classifier. So these were some baseline results, and you can use them also as starting point. If you look at the data, the code for all the baseline methods is also included. Yes. And to come to a conclusion, I just presented to you our dataset that can be used for evaluating argument recommender systems. We collected the data at different points of time so that it's possible that you, given the data from one point of time, you can always predict the data that was collected in the future. And we invite you all to develop your own tasks and improve on our results. And yes, on this link, you can look up our dataset and also the methods that we implemented, and you can develop your own task and have your own methods on it. So thank you very much for listening.